meetings, get the meetup going, and then we'll do question and answer after we stop recording and the live broadcast. Today we're going to do something different. We're going to do 5 minutes in Q&A with Alex because he has a hard stop at 9. Since he's attending the Small Data SF conference, which I will also be attending, but staggering in late. If any of you are out there, check out the SF channel. There's a Jazz Tools event today after the meetups, and Truffalo or James might also put something together. So let's all meet up. A few of us yesterday caught up at Local Edition. Would love to see more people from the community. And this is the lineup for today. First up, we have Nick going to tell us about. I need to learn how to use the new Discord for a second. Yeah. He will be presenting. Did it work? Nope. One more second. All right. I'll hand it off to Nick to talk to us about end-to-end encryption in local first apps. We see a desktop screen, but not your presentation, Nick.
Do you see the
There
presentation now?
Perfect.
Perfect. All right. So then let's go. Hello, everybody. I'm Nick Graf, and yeah, today we'll talk about end-to-end encryption in local first apps. But why is end-to-end encryption relevant to local first? Let me elaborate. If you take a look at the 7 ideals for local first software defined by Ink and Switch, there was one of them that got me a lot more excited than the others, which is security and privacy by default, which was number 6. And there's one particular sentence I want to highlight that explains it, summarizes it really well. Local first apps can use end-to-end encryption so that any servers that store a copy of your files only hold encrypted data that they cannot read. And I really love that part. I really love the idea to, as a user, that I can decide who can actually read my data. And even if there's only certain parts of the application end-to-end encrypted, which is totally a viable option, I love the idea that like sensible stuff can be end-to-end encrypted. And I was not alone. Because there's a whole subset of the local first community that also care enough that we nowadays have plenty of frameworks and apps being built that are end-to-end encrypted. And I probably wouldn't be here and talking about this if I was not involved in building 2 of them. One is SecSync, which is a sync protocol for end-to-end encryption of CDTs, and Opaque, which is a password-based client-server authentication, but resulting in a stable private key every time, which is beautiful for which you can use as authentication for end-to-end encryption. And I did all of that to build one application, which is called Serenity. It's not out yet, but yeah, basically the goal was to build this app, and with that, 2-3 years ago, I started to, well, my journey on end-to-end encryption is longer, but like really get into like how can we combine these 2 fields, and yeah, and yeah. Now let's dive right into end-to-end encryption. And while I would love to start with like really hardcore definitions and have you here for weeks and months and go through the whole field, we have to skip that, and we will go a bit more high level and look at 4 different key areas, which I believe are a good separation of concerns. What kind of like key areas you need to make end-to-end encryption for local first apps reality. Yeah, and the first one, which is a hot topic in local first in general at the moment, is sync protocols, and this is the one we're gonna start. So we have sync, key agreement, establishing trust and identity. And we'll dive into like what it means, and for each of them I show you a bit of a comparison of what actual frameworks that we have use nowadays and how to implement it, and so have this comparison so you can also get a feeling for it and make better decisions, understand the trade-offs and so on. So let's talk about sync. And sync for me started like couple years back, even before local first was a thing. My question back then was like, why are only messenger apps are end-to-end encrypted? And the interesting thing, or the answer was pretty quickly found, is messaging apps don't have this problem of conflicts. You just send messages and maybe you edit them, but it's just another message to change an existing message. But you're not really collaborating on like one document or one database. It's just a list of items, and that's why it's a lot easier to do, or you have less trouble. And what do I mean with conflicts? Maybe some of you have seen this. You're editing a file on a flight, or just have briefly, actually, you're just editing at the same time, and then sync happens, and you get this pop up, and it can come in various situations. It happens in all sorts of um, uh, sync situations, that you get these conflicts, and then you have to merge them manually, and it can become really a pain, and tricky to deal with. Uh, there is a solution, and for example, Google Docs is the good experience that we have seen, which is really beautiful. You just edit, and it just works, and it merges it automatically. But the problem with this is Google Docs, for example, uses technology called operational transform. And the issue with that one is the server, syncing server, needs to see the content in clear text. So end-to-end encryption does not work with operational transform because the server needs to have access. And this is a problem. And this is why, for example, there is a new version of Google Docs, which is end-to-end encrypted, but basically they're falling back to the same thing as like Microsoft. Like, you cannot work on one Google Doc in parallel. You can only have like one at a time and so on, because you cannot make syncing happening in this case. And so we are basically, if we want to have end-to-end encryption, collaborating on the same data, we have this problem again of conflicts. And maybe with rich text or just text, it's okay to resolve them. But like, if you think about just Excel sheets, it becomes a lot more challenging, like how to merge multiple Excel sheets together. Or if you think about database changes, if you put that burden to a user, that's really, really tough. And the solution is to just combine it with this technology, our data structures that we use heavily in local first steps, which are the CADTs. And let me illustrate this by an example, how this actually can work, or how this makes it really, really nice and easy to combine, and why it works. Is one example would be, let's say I have a to-do app and I'm adding a to-do, and I'm basically syncing this to-do to another user, and then both users do a different change on this to-do at the same time, and then it starts syncing. And this is exactly where this conflict should arise. But the beauty of CADTs is it doesn't matter how you apply these changes, in which order, they always will result to the same end result. But they always result in the same structure. And this is really, really beautiful, because if you have this CADT concept and they are all like eventual consistent and result in the same result, then you can do something very beautiful. You can encrypt every change separately, and it doesn't matter the order again, how you send them across. Every client will end up in the same state, and that's beautiful. And this is why end-to-end encryption and CADTs are such a great love story. And that means I can take basically any kind of an end-to-end encryption protocol, put a CADT in there, and you have it working. And you can combine these, and it just works. And for example, Yusuf, someone from the local first community, did this. He just forked the Signal client, the desktop app, and put a rich text editor in there with a CADT that syncs over a CADT. And yeah, he got real-time collaborative editing working over the best known end-to-end encryption protocol, Signal. And that's really, really fantastic. Yeah, and this is how sync can be achieved. Uh, there's one gotcha though that before we move on to the next theme or area that I wanna highlight, and that is, and I want to do this with showing you some stats on AutoMerge and YGS performance. The problem is if you encrypt every change separately and then um, decrypt it and send them across over a sync protocol, you get to a lot of data. Keep in mind, this data is just the raw auto-merge changes. This is not even encryption included. This is so, for example, if I have a document with 10,000 changes, it becomes, this is tracking of characters. It's from a paper that Martin Kleppmann wrote, and he tracked basically every change is like one character in a paper, one deletion. And you see that 10,000 changes, which is the full thing was 250,000 changes. I just took the first 10,000, which is roughly like how you would write a blog post with a lot of like back and forth. Maybe it's a longer blog post, but yeah, can be a good amount of changes. Is already quite big in terms of data. It's like 1.4 megabyte. And if you compare that to this function where you do auto-merge.save, which I call a snapshot, or you can call it compaction, is a lot smaller. And this is because AutoMerge or YJS and many other CADT libraries have this concept of compressing data. And this is really beautiful. The difference is so immense. In terms of loading times, you don't see much changes here. But you can see that, having all the changes encrypted separately is a bit problematic. And if you look at AutoMerge document with 250,000 changes, you can see that this can become really problematic because 38 megabytes for downloading one document is quite heavy. You don't want to do that over the web. Also, the loading times in general for very large documents are not ideal yet in AutoMerge. They're working on it, so they're speeding it up. But yeah, at least downloading like basically a snapshot from it, that this compressed file of changes, is the difference is vast. And I did some experiments. It's like for designing a protocol, basically how would the impact would be if I take 249,000 changes, compact them or like compress them, and then only apply the last 1,000 changes. And you can see in terms of data, this is still very acceptable. So you can design a protocol where you have snapshots, apply changes, which is good for real-time collaboration, and then now and then a new snapshot should be taken. And yeah, no significant impact in terms of loading times. Well, some, or not compared to the actual snapshot loading, but it's not much better with YGS. You also have quite a difference here in terms of like snapshot and changes. Again, for a smaller 10,000 changes document, and yeah, also for YGS it's 11 megabytes if you only have the changes, which is not ideal. And you can see here you also have a lot longer loading times. Well, this is only like a tenth of it if you do this. So snapshots and compaction to the rescue, and it's really exciting that some libraries are supporting this and more are doing so. Which brings me to what existing frameworks and libraries do nowadays. So I want to give you, if you have very small documents, you probably don't need compaction. But you care about other properties. This is why I want to give you these tables for each theme or segment to give you an insight, like what are the pros, what are the cons, and depending on the application that you want to build, it's like what do I need to care about, and yeah, make your own choices. So using some of them, Evolu, DXUS, Chess, Beehive. Beehive is something that Ink and Switch is working on, so this is more theory than practice at the moment. But they published a post basically describing how they want to implement yeah, a new layer that allows you to do the whole authentication or authorization part and key agreement, and basically becomes kind of a bit of a framework. Well, yeah, maybe. And then SecSync is this one library that I worked on, as said, because we had the need to there was no syncing library back then when we started working for end-to-end encrypted CADTs. Yeah, and you can see most of them are multiplayer supported. Evolo is the only one which is not, which makes, so if you have a single player app, Evolo could take quite a different, yeah, could do quite different decisions. But yeah, you're limited to single player. And for example, what's interesting, all of them except DXUS have a custom server for syncing. In DXUS, you have the limitation that basically the other user has to be online for syncing to happen. Otherwise, you just continue working locally. And yeah, they might want to add a sync server in the future, but as far as I understood, the current system doesn't allow it. And what's also very interesting is that these sync solutions in these different frameworks or libraries have quite an impact on like what data structures you can use. So for example, Evolu uses the last write win CRDT, which overrides the cell in SQLite storage. So you have the benefit of like when building an application, you have a full SQLite storage that you can use. And that's beautiful because it's not document based, and yeah, but it only is single player. Jazz, for example, also implements their own core values, which is a CRDT, if I understood correctly. But then, for example, DXUS, Beehive, Beehive might support other things, but yeah, I mean, it's heavily focused on auto merge, and yeah, SecSync in the demos you can see YJS and auto merge. And yeah, compaction, for example, Beehive auto merge is adding compaction at the moment, or did already. They have, I mean, they have this snapshot capability, but they will also allow to compact a range of changes, and so this will directly be leveraged by Beehive, and yeah, SecSync is the only one at this point using it. DXUS, I don't know.
Quick time
I
check,
would
Nick. You
need
got
to.
another 5.
Yeah, thank you. And yeah, uh, then one important thing for a lot of people is it decentralized? As far as understood, Evolo, you can easily take it and sync it to a different server and it will be fine. For DXUS, I don't know. I mean, it only syncs via WebRTC, but yeah, so that probably might be fine for decentralization, but I don't know but other parts, if they have to use the sync server. For Chess, I'm also not really aware, and Beehive will be decentralized. SecSync, for example, requires a central sync server. And yeah, these are basically the trade-offs. Let's move on to the second section, which will be a lot faster. I really wanted to focus on sync. That's why, yeah, because it's it has an impact. It's quite an impact on your choices. The second big topic is key agreement. So if you have these changes or snapshot that you encrypt, you always need a key that you agree in a group if you have collaboration. And like sharing key is not so tricky. The tricky thing is key rotation. So let's say you want to you're removing a member from a group. You basically need to rotate the key. You need to make sure that every new encryption um, is happening with a new key. You need to distribute that key, and but you still need to have access to the old keys, because if you want to get the old messages or the old changes or an old snapshot that was encrypted with an old key. So the thing about it becomes quite a complex key management problem, and luckily there are existing solutions that are being standardized. MLS is one, um, and that's like very, very exciting, and probably what you use, except you want to have it really distributed, decentralized, because MLS needs a central server that syncs or does some like does some ordering of events, or basically gives assurance that the events are in a certain order. And then there's an interesting paper which Martin Kleppmann was also involved, and Matthew Widener, for a decentralized algorithm. And I think this will be up and coming and used by a lot more. And but what we see, if you look at frameworks, most of them are using custom solution with lockboxes or not at all. And yeah, this is the current state. Let's move on to the third point of the four, which is establishing trust. Establishing trust is quite interesting in existing systems like Signal, WhatsApp, and so on. You have this concept of trust on first use. So basically, if you contact someone, you're actually trusting the server that they send you the correct keys, public keys, so you can establish an end-to-end encrypted session with someone else, and you can check it then with there's some security numbers that you can compare out of band, but it's quite, in the end you're still trusting Signal a lot, and or WhatsApp or whoever. And so one other topic, and this is basically becoming very famous in the local first community, is just using sidechain tokens or invitation links. It doesn't have to be sidechain tokens, but sidechain tokens were the first like bringing this up, and they kind of reinvented the idea of like how to do this properly by Keybase. And now we see a lot frameworks and so on adopting it. And it's so beautiful because in URLs, in the hash part, you can simply put a key, and this part is never sent to a server, and this makes it really nice to establish end-to-end encryption out of band. You just send someone a link, and you can make sure that this basically expires after 2 days. This requires some trust to a server again, but you can make end-to-end encryption, this trust part, establishing trust part, really happen. And one problem though with sidechain tokens is that a user has to be online. So this is something I tackled in a proposal. If you want to check it out, just take it and steal it. This is something I thought about in the summer, and finally wrote it down 2 weeks ago. And hopefully this is helpful. And you see basically everybody is using link invitations. And the last one, the last big section you need to care about is identity. So the thing is, like, how do you authenticate yourself in an end-to-end encrypted system? You need some kind of like, usually it's private public key system, or in case of Evolu, you don't even need this, but usually it's like you want to have this authentication or identity so that others can send you stuff encrypted. And there's various solutions to this. You can use a mnemonic, what you maybe used to in Bitcoin wallets and so on, crypto wallets. Passkey is becoming interesting because very recently there was a definition of the PRF extension, which allows you to, from passkeys, to get a stable private key out, which you then can use for your applications. And there were tricks to get this working. I don't know if they really were secure and and good, but the PRF extension is the official thing, and with this passkeys become very interesting. There's the OPEC protocol, which I'm very excited about because it allows you at least to give this give this classic behavior of username, a password, so people are used to this. And then a lot of people are working on their own like user device structure in combination with these others, and then storing the data locally. And while I'm very excited about it, I would love to talk more bit more about OPEC, but I'm running out of time, so we skip over this and probably we'll talk about this another time. But if you're curious to just make username password happing for end-to-end encryption, it's possible. Yeah, it requires involvement from the server, but it's a secure protocol. It's becoming in. There was a paper and it's becoming an RFC, and Facebook is actually using it as a Rust library in the to end-to-end encrypted backups of WhatsApp, and we built a TypeScript bindings to it and a very clean library. And yeah, this was audited professionally and also our library. So yeah, we think it's really good. And yeah, obviously there's various different solutions. And yeah, for example, Evolu, yeah, the only way to do it is a mnemonic, which I'm not too excited about, but it's at least very simple, and that's if you like that, then that's a great choice. And then what's very interesting, basically various different systems create their own devices with local storage, and then different solutions how to actually log in. And yeah, I'm not sure where Beehive will go, but maybe that's something you can ask. I think tomorrow is the Ink and Switch or Autosh Q&A. So that might be a nice place to drop by and yeah, get more info. Yeah. So to recap, we looked at these 4 areas that you need to combine to enable end-to-end encryption for local first steps. The good thing is there are frameworks that are already doing this, so you don't have to reinvent the wheel. You can just use them, but if you need something special, you can maybe take parts of it or combine different libraries that I or others built. And yeah, I hope this was insightful, and maybe you got excited and will actually build an end-to-end encrypted local first step. Thank you very much.
Awesome talk, Nick, and also love seeing WebAuthn up there. Passkeys have really changed the game. It was always like encryption by obfuscation if you have to keep the private key with your app, and nowadays you have this out of band thing that can like give you the private key once you've authenticated. A couple of demos, a lot of exciting kind of work being done in this space. Next up, we have Alex, and it's gonna be amazing. I've had the chance to kind of poke around what he's been up to. Zero dependency vibes, everything just local, and just how much horsepower he's put towards what you can do in one device is amazing. Uh, just for the sake of time, you guys can forward your questions to Alex. I definitely want to make sure we have a lot of time for Steve as well. So over to you, Alex.
For sure. Thank you. Let me know if you can hear me and my screen's working and everything. Better share my
I can
screen.
hear you. Sharing hasn't started yet.
Cool. Let me do that real quick. Perfect. How's that?
Yep, you're coming in great.
Awesome. Um, So hello everyone, my name is Alex Garcia. I'm the creator of sqlite-vec. It is a open source library for vector search using SQLite. It is MIT licensed, Apache 2 licensed. So you should have there should be no worries there if you're trying to use it in any products or anything. So completely open source, completely available to you. It is again a SQLite extension. I unfortunately don't have too much time to talk about why vector search is very cool and all the cool things you could do with it. But as a quick uh, general overview, semantic search is a very big thing that people build using vector search. If you already have a search engine of types in your local search applications, it's probably keyword search, where it searches for specific keywords on whatever the query input is. whereas semantic search can derive value from whatever the query has. So for example, if you want to search up climate change, it won't match documents that match like global warming or anything like that, because climate change and global warming don't match keyword sense. But semantic search would be able to get that. So, if you look up global warming, you can get climate change. If you look up other related words like scary orange holiday, it could infer that you're talking about Halloween, that kind of thing. That's one big benefit that semantic search has over keyword search, and that is one of the main use cases people have for vector search in general. It's also great for RAG applications or retrieval augmented generation applications if you're doing a lot of AI stuff. So, you have an LLM or some, big AI thing and you want to feed it chunks or context from like internal private documents or something. Vector search is also good for that, basically a fancier search style. And you can also build like small little lightweight classifiers. So for example, if you have like a note-taking application and you want to attach labels to those notes, what you could do is you can embed a note, figure out like the closest notes that semantically are similar to this new note, see what labels those have, and prompt the user to be like, oh, you took other notes that also use these keywords and very similar to this, and it had this label. Do you want to add this label? You can do small things like that. So embeddings in vector search, very interesting. Definitely check it out. SQLite-vec is one way to do vector search. I think it's pretty great using SQLite. It is pure SQL. So for example, this is all you would need for a general like vector search application. So first off, you have a create table statement, right? This is where you declare, I have a table called, in this example that we have here, this is an application that has embeddings of headlines from news articles. So, a headline that says something like, oh, global warming happening in Nicaragua or something, right? So this is a sample application where we're embedding that headline and we're doing vector search on top of it. So in this case, it is a virtual table that we use, since SQLite is an extension and it uses virtual tables extensively, where we declare that there's an article ID, which is a primary key, a headline embedding, which is a float column with 384 dimensions, and that's configurable to whatever vector source or embeddings library you use. You could seed that table with just a regular insert into statement. So you could insert into the virtual table you created and then feed in the data that you have itself, feeding in the row ID and an embedded version of that headline. In this case, this embed function doesn't exist in SQLite-vec. You'd have to generate it yourself. So for example, if you want to, generate embeddings from like OpenAI or Ollama or Llama or whatever other embeddings generator service that's possible, you could use that with SQLite. All you have to do is provide it as JSON or as a compact blob, which is talked about in the documentation. And you can insert directly into these virtual tables and it would just handle it just like that. And finally, after you have all that data inserted, a KNN query is just a SQL statement. It's just a select all from vec headlines where we do this match operation on the headline embeddings column. And this is a signal to SQLite-vec to do a KNN style search. So in this case, we want to say, okay, we want the 10 closest vectors in this table that match this given query. So we're using that same embed function that we had above. We're embedding a user query, whether it's climate change or global warming, and we're getting the 10 closest documents to that given that query. So again, this is all in SQL. Create, insert, select. That's all you need to do vector search in SQLite and SQLite-vec. Now, I spent a lot of time to make sure that SQLite-vec is easy to use across programming languages and across platforms and devices and all. So these are all different, totally valid ways to install SQLite-vec. You could pip install for Python, npm install for JavaScript, Node.js, Dino, Bun, all that stuff. Gem install for Ruby applications. There's dataset and SQLite utils plugins for those as well. Those are some libraries created by Simon Wilson, which are very SQLite related, but that's another way to install them. If you're using Rust, you can cargo add SQLite-vec, and it's a library that will embed it into your Rust applications. There are two different Go bindings for this, if you're using CGO or if you're using another SQLite Go library that uses a WebAssembly instead of CGO. So that's another way to install SQLite-vec into applications. If you want to YOLO it and do a curl this install script into your shell, totally valid as well. It will just download whatever platform is needed for you. And SQLite-vec, at the end of the day, it's just a single C file. So you could compile it yourself just using GCC whatever, output into a loadable library. You could do that yourself if you just want to install it into whatever esoteric system that you have. And what's nice about SQLite-vec being written completely in C is that it could also compile into WebAssembly. This is a quick demo of what that looks like. So this is a SQLite-vec compiled into WebAssembly using the official SQLite WebAssembly JavaScript library that exists. To use it, it's just a single import statement. You initialize the database, and you have these SQL functions that are available to you. So you can see here, we do a select using the API that this JavaScript library has. This vec version function, that's a signal saying that SQLite-vec is installed here, and you could use it in WebAssembly. Ideally, it should work with some of those different WebAssembly file storage formats, so like OPVFS and stuff like that. There's still a little bit of bugs that I have to fix here and there, but ideally, once that's completed, you could use this in local first applications, save it on save it in that environment. So that way, when people visit your website, it'll keep it saved in their browser. No other everything local, no other remote connections needed. So SQLite-vec does support WebAssembly to an extent. It also can run on other smaller platforms like Raspberry Pis. So for example, let me make sure that you can see me. Um,
Yep.
I hope you can see me. I'm pretty sure you can. But I have a BP device that's right here. It is a Raspberry Pi Zero with an e-ink display and a BlackBerry keyboard, and I can run SQLite-vec on here. You may not be able to see it, but I have a little Python program that's running on this e-ink display where I type in a query, I hit enter, and it'll return the 10 closest news articles that had to do with my query, right? So, I type in climate change, it'll return stuff about global warming and other climate related news. Or I'll type in, Kamala Harris, and it'll talk about like presidential news or things like that, right? Or White House or all these things. Again, not just keyword search, it could also do vector search. So it's more of the semantic meaning, and it's running on this little device. And this device has, like 250 megabytes of RAM. It's fairly small, and it can still run SQLite-vec and do everything local on here. No Wi-Fi, no anything needed on this little device. Um, I also have experimental support for Android and iOS. I'm still working on it. I have precompiled share object files that are loadable in Android and iOS. They're a little bit hard to use, but it is like technically possible. So if you're using Turnbox or something as a quick, just to try it out, it should work on these platforms. I will publish proper AAR files for Android and an XD framework files for iOS very soon. And I believe that should make it a lot easier to use in, Android Studio projects and Xcode and whatever the platforms that exist there. I will say that OP SQLite, which is a React Native binding for SQLite, they did add SQLite-vec support directly inside of there. So it's just like there's a configuration file, you just put SQLite-vec true, and it'll compile SQLite and include it in there as well. So if you are using React Native, if you do want that, that is available in OP SQLite. And for all other Android platforms, I'll be publishing some better support for those relatively soon. Also with SQLite-vec, it is embeddable. So, again, it is a single C file and a single H header file. No other dependencies are needed. Everything is bundled inside there. So all the JSON parsing, all the, cosine, L2, distance similarities, all that stuff is written completely in C. So you could statically build it into like your pre-existing C, Rust, or Go projects. You could drop it into any C compiler or CMake or other C projects, and it should just work out of the box as normal. I would say there are a few unique things to SQLite-vec compared to the many other vector search libraries that are out there. The biggest one, I think, is that it doesn't store everything in memory, which a lot of other ones do, and that could really, exhaust resources, especially in local first applications. Instead, SQLite-vec will read chunks at a time, right? So if you have like a million vectors, it'll only read maybe a couple hundred or 1,000 at a time, and then do comparisons off that. It does mean it's a little bit slower, and especially since SQLite-vec is just brute force now, there is no approximate nearest neighbors or anything. So it's a bit slower. The practical limit is much lower than other ones. So it's around like, it could definitely handle hundreds or thousands or tens of thousands of vectors just fine. You wouldn't notice a difference. I would say there's a practical limit of like hundreds of thousands of vectors where things really slow down, where like, it takes longer than a second to do a search of those. So it really depends like how big your data is and how big your applications are and how many vectors they're using. I would say with a lot of local first applications, you probably have like it's probably going to be in the tens of thousands of vectors. You could think of a personal knowledge management system. They probably don't have like millions of documents to search. They might, but it's probably going to be in the tens of thousands. So SQLite-vec could be a good opportunity there. There is support for binary quantization and Matryoshka embeddings, which could help out a little bit and make that a little bit better and make it will reduce the size of your vector index and make searches much better, much faster. And you can kind of hit some higher limits with those at the expense of quality and all that. So there's some trade-offs there. So there are ways to like kind of work around that, but for now it is brute force only, doesn't store everything in memory, so it will be a little bit slower in some of those cases. It also doesn't do embeddings. Some other vector search applications out there, they will have plugin so that way it'll hit OpenAI for you, or it'll hit these like local models if you and kind of handle everything for you. SQLite doesn't do any of that. It just stores vectors. You give it your own you bring your own embeddings, you store them, and that's it. Which gives you a lot of flexibility. You can choose whatever embeddings library that you want, any third-party provider, any local embeddings. All you have to do is provide it as JSON or as a compact blob, and that's all you need. Just provide it as that, and then we're good to go. Another nice thing about sqlite-vec is that it is all SQL. There are no other third-party libraries or different APIs to consider. So, for example, this again, like previous example that we have a create table statement, we insert into that, and then we select for a KNN query. Those are the three main operations that you need, all in SQL. So in this Python demo, it is the same thing. There is a create, there is an insert, and there's a KNN query, and that's it. There's no other, different types of queries needed. It's just those three base SQL queries. Same thing in JavaScript. Create, insert, select. There is the glue around here is a little bit different because JavaScript bindings are different in Python, but it's still the same SQL under the hood. Same thing for Ruby. Same SQL. Create, insert, select. A little bit different glue code, but the core SQL is the exact same. Also the same in Rust. Same SQL, different glue code. Even in C, it is the same SQL, just different glue code. So that's one really nice thing about sqlite-vec is that it is all SQL. If you're adding a different platform or different device, it's still going to be the same API that you talk with using SQL. That also means you could do things like build a SQLite database on a Jupyter notebook or on a big server where you have all this, uh, access to faster embeddings and a bunch more memory. You could build that in a separate place and then just copy that file onto local devices, into the web browser, into Raspberry Pis or whatever, and it will just work out of the box because again, it's just SQL that it's using for all these KNN queries. It works across programming languages. It's fairly nice for SQLite-vec specifically. And I would say for SQL, for local first in general, SQLite is a great choice. It's as local as it gets. It's a single file. There's no other configuration or server that's needed. There's no outside dependencies, so you don't have to worry about like installing PyTorch or installing these esoteric build systems. It is all like just a single C file, very easy to compile, probably keep pre-compiled for you. And there's probably a package manager out there for your programming language that already compiles SQLite for you, so you don't really have to do much. It's just a npm install or pip install away. Databases are just a file, so it's very easy to save either locally on a user's computer, or if you want to back it up to S3 with Lightstream, or do replication, or all this other stuff. There's a lot of different options you have out there. Also, if you do reach a point where you kind of want to have a SaaS option where you have like multiple users, but you still want to use SQLite Cloud, there are a few different options available there. Of course, not all of them are open source, but if you want to use Terso or D1 or SQLite Cloud to do that kind of like multi-tenant sort of thing, where like you have multiple one database per user, those are SaaS options that are available to you if you want to go outside of like local first, right? Uh, I would say that there are a few things that still need to be solved for SQLite-vec. So for example, syncing and CRDTs still a little bit difficult to do in SQLite, and SQLite-vec might make that a little bit harder. I know there are a few plugins and extensions that are out there, but they might be a little bit incompatible with SQLite-vec. If you do have a problem with those, let me know because I definitely want to make that a little bit better and would love to include support for those. So if you do try that out, let me know. And also end-to-end encryption is still a little bit hard. It should work. SQLite-vec should work with SQL Cipher, which is a fork of SQLite that includes some encryption stuff. And there's also a proprietary SEE, I forgot the name of it. I think it's like SQLite encrypted extension. That's a proprietary thing that you buy from the SQLite team itself. It should work with those out of the box, but I've never tried it myself. So that is one thing to consider about using that. That syncing and end-to-end encryption might be solved in SQLite, just haven't tried it in SQLite-vec specifically. So definitely let me know if you run into any problems with trying those out. And lastly, a quick shout out. I have a few other related projects. These are also other SQLite extensions that have to do with vectors embeddings. First one is SQLite L-embed, which is for local embeddings. It uses llama.cpp to do embeddings generations all locally, no extra server configuration needed. And I also have SQLite R-embed, which is for remote embeddings, and that'll handle hitting OpenAI server, Llama file, Ollama, all those other third-party REST APIs that are needed to generate embeddings. It does a lot of that for you. So again, this is just like SQLite-vec. It is all they're SQLite extensions that run entirely in SQL. Here's an example of how those work. It is a quick configuration update with an insert into statement. And then from there, you get a single function called lembed or rembed that will embed these files for you. So that's SQLite-vec. I will be around in the LoFi Discord channel. There's an AI Discord channel in the LoFi Discord server. Happy to answer any questions there. There's also separate a separate Discord channel for sqlite-vec in the Mozilla AI Discord server that I'm happy to answer questions in there as well. And feel free to always, drop an issue in GitHub or message me on Discord or email me if you ever have any questions about how to use sqlite-vec or help, or if you want help embedding it into your applications. More than happy to make that work.
Awesome talk, Alex. And I've mentioned it a couple of times. I'm a big fan of what they're up to, or what he's up to. And I'm one of the people that kind of like help fund the Op SQLite integration. And one of the things that kind of resulted in it was this beautiful experience that uh, came out. What is this? I'm sorry, folks. Like Discord decided to change how things get shared anymore, and now it's like a big pain. So one thing that we've kind of been able to do is this is for Vela. You got a lot of these emails that are stupid. How do you cluster them into really nice categories? You can do like neighborhood search with like fine-tuned ones. We had a fine-tuned Distilbert implementation, and now we're moving to a SQLite-vec that kind of tries to have an embedding centroid and gather these things. This is one great use case of how to use sort of embedding beyond embedding search for situations where you are trying to say like, okay, I have a general vibe that I want to tackle and be able to do that effectively. And this is Vela. Would love to have some people test and help test it for us. We're building interfaces and experiences like auto tagging, but more importantly, like really cool things where you clear really noisy things out of your inbox, and figured I'd give that plug real quick because Alex really undersold the impact of what he's put together. Next up, we have an awesome speaker that doesn't need an intro, but I'll do it nonetheless. Steve, thank you so much for coming in to talk with us today. He's built Tldraw. A lot of the people here are a big fan of what you've built and looking forward to hearing how your journey has been and the make real. It's quite magical. Over to you. I I don't hear you. I don't know if it's the same for other people as well. Maybe check your input. No sound.
All right, let's try that.
Yep, you're coming in great now. We see your screen, but
See that?
I don't know if it's Discord you want to share.
Yeah, no kidding. Oh wait, there we go. Here, I'll upgrade the audio a little bit. Is that better?
Yeah, you got some
All right,
nice
cool.
bass to it now.
Yeah, right on. Get the whole radio voice experience. Hey, welcome to London. I'm Steve. Um, Dialing in here from the Tldraw office. Uh, Let me introduce you to Tldraw. You've probably seen Tldraw on Twitter, which is where I spend most of my time. I'll give you the real brief introduction, but there's probably some parts of here that you might not have ever. Maybe people know Tldraw for different reasons. So Tldraw is a kind of an online, a digital whiteboard. It grew out of a project that I did called Perfect Freehand, where I was kind of experimenting with the variable width lines. You can kind of see the algorithm in practice here, where like I'm taking an input of points and then trying to figure out what is a like a polygon that kind of wraps these points around. And I wanted to have it use pressure, like the pressure of your device, or tapering, or like simulate that pressure based on how fast you move your cursor. So if you ever want to play with this, it's at perfectfreehand.com, and you can kind of just play with all the kind of the dials and hooks and stuff. But that came out really well, and led into building just like a whiteboard, and then that got really popular. So the basic idea is that we have a infinite canvas. You can zoom in, zoom out, do all the things that you're used to in something like Figma or Miro, FigJam, things like that. Big difference is that the canvas itself is it is made out of normal web stuff. So I kind of use the example of Notion. Notion looks like a document editor, but it's just a website. Likewise, Tldraw looks like a graphics editor, but it is also a website. So you can do things like paste in links. So if I go to Google Maps and grab some, like, this is where our office is, I can just take that and like paste it into Tldraw, and it gives me a nice shape that I can still resize or rotate or do all these things to. But I could also double click into it and interact with the embed itself, because it's just like it's an embed. It's just a little part of the website inside of the other website. So when you see a big Tldraw file, like, these are all divs and SVGs inside of divs and things like that. Does it work? Yeah, surprisingly, it actually works. It is, you can use it for pretty much whatever you want. We use it for our retros and all sorts of stuff, but it turned out to have a lot of uses outside of just uh, normal whiteboarding stuff. So we distribute it as an SDK. Other people can use it, can plug it into their projects. If you want to use it, do it. There's no. It used to be under a non-commercial license. We've actually just gotten rid of that, but we do have a little watermark here in the corner. It will take us back to tldraw.dev. If you want to get rid of that watermark, then I have a wonderful sales guy in San Diego who can talk to you and figure out a price and stuff like that. The good news is that actually there is a kind of a market for this. That there's a lot of products that would love to have this type of experience inside of them, namely because it's like cool and also really difficult. So a good example is Craft, which this is my favorite example to use because Craft is such a beautiful product, and it sort of uses design as like the big selling point really for the product. But whiteboards in Craft, which you can just drag in or do the little slash stuff, um, that is in beta, but it's also like Tldraw. This is the same, um, you know, basically the same app that we just looked at, just but reskinned and displayed in a different way, um, which is great. Those are all the things that you can do with Tldraw that I hope that people do. And there's really cool stuff like, I don't know, arrows that are you know let's see if I can change the shape of this. Uh, I'll do it inside of Craft because why not? But like I like obsessed about the arrow quality, so like the arrows will like follow the geometry of the shapes that surround the stuff. And uh, what's another good example? Like you can even I'll forget it. I'll do it. I wasn't planning to, but I'll do it.
Let's go.
You can look at uh, you can even kind of like inspect some of like how this works, like and view the geometry inside of Tldraw in order to kind of like see how those arrows are being drawn, or how the points of the polyline are being intersected, all those types of things. It's really kind of a fun app to have worked on, but it's also a fun app to like kind of look at and use, especially as a developer, um, because like, hey, it's a 2D canvas. Like you can do whatever you want with a 2D canvas. A great example is like Grant Cott had this super cool like liquid simulation. You can all see this correctly, right?
Yeah.
Yeah. Um, and he took Tldraw and started playing with those two things together. So uh, now the canvas sort of is the surface into which or like defines the geometry that is interacting with the liquid. So all of these kind of like the geometry that I just showed over here is like being represented in the physical the physics of his engine. And he even tied into let's see if I can do it. I think it's like if you have a box and it has a specific kind of like, yeah, there we go, a check to it, it'll start producing. And if you have another box that has like an X through it, it'll start removing the stuff. And I can draw, and it'll kind of like play around the shapes that I make on the canvas. It is insane.
That is
I've
just
never
wild.
expected. I hope that this is coming across. It's grantcott.com slash
Amazing.
yeah, it's like that. grantcott.com/draw for this. Um, Incredible. There's also like a version of this that actually uses the camera so that it kind of projects your body onto the canvas as a certain geometry. So pretty wild. Other people have made like this is Dennis's project Holograph, which is just kind of like a I think the technical term is propagator network, but it is it's basically like a spreadsheet. It's a computer. It's like as values change, they propagate through the network. So this calculates Fahrenheit, but it can also go the other direction and calculate centigrade by like pushing data in and doing uh, basically like transforms on that data. And this is at holograph.so. The stuff that you can build with this is actually pretty crazy. Like uh, I've seen, like I think this is a game where the cat is going to chase this mouse based on its position on the board. So if I turn the cat and make it active, it should. Well, maybe it's chasing where the mouse was before. Hang on a second. Let me turn this 0, then back to 1. Is it ever going to catch it? Well, this is more Dennis's demo than my demo, but you'll have to play with it yourself. Uh, it's a really cool use of the canvas. The HCI community seems to really like it as well. Just there's people have made like neural networks in this. It's pretty nuts. So another good example there. Um, for us, we also have played with our own toys, I suppose. Uh, and the most popular one of those is Make Real. There's also teach.tldraw.com, which I can show you as well. Although for this, we finally introduced authentication for the very first time. And yeah, I guess we're building an app as well, but that's secret. So, you know, keep an eye out. Um, the the idea with teach.com is that you have this prompt, and we're teaching it to like um, we're teaching the model to use the canvas. So in this case, I just put in a prompt called whatever, draw Batman, um, and the the things that it's going to be creating are the same things that I can create, right? Um, and that's kind of novel. Like we're used to image generators or things like that, but we're not really used to having this back and forth um, between things that we do and the things that the model does. So if I give him like a an eye like this, never done this before, but it's a little bit like live coding, and I ask to like draw the other eye. Um, it we send it a screenshot. We also send it like a kind of a XML format of what's on the canvas, and then hey, there we go. So it's able to sort of interpret my stuff as well as its own stuff, and like kind of have a back and forth there. You can imagine that this is like a really dumb initial step towards having a kind of a true canvas collaboration with a AI model using Tldraw. Again, this is you can go play with this right now. It's teach.tldraw.com. It's free. We have a whole bunch of Anthropic credits that we're burning through. Um, Good example of like what it can do also is like graphs a little bit. It's kind of weird. It's not really good at anything, but it is pretty um, like how do I say that? It's amazing, even though it kind of sucks. So that's exactly the state of the art, which hopefully looks good in Tldraw, where it wouldn't look good in other software. Um, Plot, Microsoft, and Adobe um, from 1970 to 2020, something like that. Even though it's bad at drawing, it's good at everything else. Like it has all the knowledge of the products, or just like of the whole world, right? Like it has all that embedded information, even though it's quite bad at expressing it. Add Facebook to the graph, um, and then I'll do like this, like change the time from 1970 to 2020 uh, to 2015 to 2020 instead. Um, and it can also like edit its own work. So we just saw it add something, but I think it should be able to do this where, well, that doesn't really make sense, but you know what I mean. It'll get there. Um, so that's teach. That's very much kind of like in this world of autocomplete and teaching the model to make interventions into the canvas. Hopefully, we get it to a point where it's fast enough and it's good enough that it can really like kind of be a kind of co-pilot, a collaborative partner to you as you're working on the canvas. Make real was the first thing that really got popular. This you will have to put in your own API key for, which definitely has reduced the number of people who can successfully get onto this. But on the other hand, there are like this this thing when we published it in November, it was just like the hottest thing on the internet for like 3 weeks. Um, it was really a great experience as a startup founder watching everyone suddenly know about your little little whiteboard SDK thing. Um, but the basic idea is that like the we can in Tldraw you can generate screenshots, right? Like I can just make a screenshot. I can crop the screenshot, etc. It's just an image. You can make a lot of images very easily in Tldraw. With this project, we're getting that image and we are sending it off to an LLM, and we're saying, hey, actually, I can grab the entire system prompt here. We're saying, hey, you are a web developer who turns you basically build working website prototypes from low fidelity wireframes. You take the low fidelity designs, you turn them into working HTML stuff. We have a little prompt saying, here's how you do styling, or here's, like just little bug fixes, like make sure you use type module, otherwise your async stuff is not going to work, et cetera, et cetera. But, and the results are pretty good. Like the models are very good at writing code, and they're also pretty good at deriving intent from what you give it. So in this case, we're giving it two things. We're giving it like a user interface, but we're also giving it a state machine that I drew of like, here's how it should work. We could also just give it the UI. It's actually pretty good these days at figuring this stuff out. Um, but sure enough, here's our working website. And since our canvas is made out of internet stuff, out of browser primitives, like we can just put the entire iframe onto the canvas. So in this case, I double click in, and now I can actually interact with it. And it should work the way that we wanted. This is without the accompanying state chart. Does it still work? Did it kind of pick up my intention? Yeah, cool. It did. Um, Now, the really interesting part, the place where this really gets kind of cool, is that we can also like create a screenshot of that website. And what what this means is that we can uh, draw on top of that website and then send back our notes, like change this text to uh, reset with with four exclamation points or something. Make this serif. Um, make time happen at twice normal speed. I don't know. You know what I mean? Like you kind of just mark this up and then use that as the new prompt. And what it does is if you have previous generations inside of the prompt, it also like kind of includes like, hey, this is what you had last time. Here's the feedback that you got. Incorporate the feedback into a new design based on what you did before. So it won't start from scratch. It'll start from whatever it came up with before, but then incorporate that feedback into it. So now we have a clock that's moving at twice as fast as normal. It has the big reset thing, and it has the serif text in the header. Now I can keep going. I could go like, actually get rid of this button, blah blah blah. I won't, but I'll show you some of the other kind of cool things that it can do. And by the way, like I've seen versions of this where there are like 50 generations like in a row, because people have just dialed it in, especially non-technical people. Like it's very natural to do is like ask for something, get something back, and then say, "Oh no, no, not really. Let me do it. Let me tell you more about what exactly I need." Um, you can open this up in other like code sandboxes or something like that if you did want to edit the code. You could also copy like a permanent link to it, which is also pretty cool. Like if you do make something useful, you can share it around, you can use it, you can keep it. Like we don't get rid of these, we just post them. It's the same website that's being iframed here, so it should work just the same. Um, it works really well with like user interaction type of content. Um, if you know how to draw a kind of a, if you can just somehow express yourself to like, this is what I want to see and this is what I want to happen, like it's pretty good at like at interpreting that. So in this case I'm saying, okay, I want to have like each one of these things open up, right? And if I open it up, I want it to push down the others. So does it do it? It does. Wonderful. um, and that's not a super trivial thing to prototype. If you're a designer or something, if you want to express that, it might be a lot harder to get it across to a developer or to whoever you're working with than like just drawing it out and seeing if you can get a machine to do it. It also makes this a really good sparring partner if you are in the professionally like making these types of diagrams or designs or just specifying a feature like this. Because like, yeah, if you can get the robot to do it, you're communicating yourself pretty well. Like this is another version of that same uh, graph. I think this one came earlier, and maybe this was how I started, and like this is what I ended up with. Um, and it's interesting to see how good or how not good the system is at figuring this out based on more complicated instructions. Um, let's see if I got it. Yeah, all right. That's not exactly what I want. And so even though there's more info coming in, like this is a better result because it's just like only the info that matters. Uh, cool things that you can do with Make Real. Uh, you can use whatever you can do with a website. So in this case, I saw someone who had made like a stop motion app where like every time you press the button, it would take a photo, but it would also display your last photo like as an onion skin. I was like, oh, that's cool. Let me see if Tldraw can or Make Real can do that. And I drew it up, and I'll do the live version here as well, which I think should still work, even though I'm sharing my screen. Because yeah, I wanted like a row of thumbnails from all the pictures that I've come up with before. I want to see my camera feed, and yeah, I want to be able to take pictures. I also want to like be able to click play in order to like basically have like a GIF experience with the images. So let's see if it works. I'll double click in here. Okay, there we go. In a consistent way, and then let's see if I can play through. Hey, there we go. Kind of wrong, a little bit fucked up, but you know what? That's pretty good for having not written a line of code and just made a bunch of drawings. Um, and I could iterate. I could say like, hey, you got the aspect ratio wrong when the thing is open or something like that. Other stuff is like you can get really weird with this. So let's say I want to have like a text to speech thing that also like moves the, the mouth of the person. Like really your imagination is your only constraint here. So let me see if this one works. I think I had iterated a couple of times here, but I'll also use this to show the difference between the two models. We currently support multiple models on this. You can use Anthropic or you can use OpenAI. Um, I'll spoil it and say Anthropic is a little bit better. Hello, local first. No. Ooh, interesting. Well, let's see what OpenAI does with it. So if I switch over to OpenAI, let's see if they can come up with a 4.0 can come up with a better result. Highly disappointed here. This Anthropic usually makes it work. So let me see if I can make this work. Um, just kind of give it a little bit of encouragement. Um, and in this case, I wanted to go back to Anthropic. Uh, let's see if OpenAI got it. All right. Well, there you go. We have the mouth moving at least, you know. And this is my last try. I'm not gonna debug this. Hello, local first. No? Oh, too bad. All right. Well, I can't win them all. The people make games out of this, all sorts of stuff. So I if you want to play with this, it's at makereal.tldraw.com. Uh, it is free, but you need your own API key. That's if you want to learn how to do that, we do have a guide that will tell you all about it. But I assume this is a pretty technical crowd, so it shouldn't be super hard. Let's see if this worked. Terrible. Spacebar. Oh yeah, here we go. Can I get rid of them? Nice. All right. So uh, if you make something cool, let me know. I'll absolutely retweet it. It's a great example of what happens when you build a primitive, and I think local first gets this really well. Is that like there is a lot of work that goes into making these types of experiences, and we know it too. We have Tldraw.com. It's free. Like you can join collaborative multiplayer rooms. It's always tricky to do in a live situation, but like this works on your phone, works on wherever, um, and yeah, we do our own kind of collaboration and live backend and all that stuff, and it's a huge challenge, but once it's done, you can do so much with it. Our multiplayer engine now powers like you know I forget what the numbers are now, but like it's hundreds of thousands of connections per week for applications that are using Tldraw, not even us. And then we have like hundreds of 150, 130, 150,000 people like using Tldraw, and yeah, it's fantastic. And the thing that you can make once you have done all that work, is crazy liquid explosion whiteboards, or crazy AI stuff. Like um, it's just about building those primitives, and then seeing what the community will make with them. So I guess I'll leave that on that note. Feel free to jam if you want on Tldraw. If not, explore as much as you want. You'll see it on Twitter, or maybe in your next documentation slides, something like that. It's a nice little app. Um, cool.
That was
I
awesome.
guess I can leave it there.
Yeah, and somebody drop that link on the chat too, so that like everybody can hop on. What a strong finish. I'm gonna stop the recording now and the broadcast.